All right, so let's talk about overlapping triangles. So this is triangle ABC, 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 and BAD, BAD. Now, are these triangles congruent? And if they are, how do you know? So there's a triangle right here. And there's another triangle right here. Now they're sharing this side right here. So we know that they have one side in common. Then I see that this angle is the same as that angle. This is the corner. This is the corner of the first triangle, and this is the corner of the second triangle. So we know that this angle is the same as this angle. We know that this side AB is the same as this side BA. Then I know angle D is the same thing as angle C. So what do I have? Angle, side, angle. So they are congruent. And they're overlapping. They're going to be sharing something in this overlapping situation. Here is an example of what it looks like when it's overlapping an angle. So like angle A, triangle ABE, and triangle ADF. In this one, they're sharing angle A. So I know that they're sharing angle A in both. And I see that they're sharing angle B and angle D. Now, I know that DE is the same thing as BF, and I know that EA is the same thing as FA, which means AD is the same thing as AB. So AD is the same thing as AB. So when you pull these apart, okay, it's going to be angle, side, angle, angle, side, angle. So they are congruent as well. So here is an example of a perpendicular bisector. When you know that an isosceles triangle has caused a perpendicular bisector, because it's coming from the corner and it's cut this side in half, that only happens in an isosceles triangle, which also means that these angles are congruent. Now, if you do an angle bisector inside of a isosceles triangle, that will automatically mean that these two sides are congruent and that this is perpendicular. Okay, so a perpendicular bisector automatically means an angle bisector in an isosceles triangle, and an angle bisector automatically means a perpendicular bisector in an isosceles triangle. Now, here, if you have an angle and you cut the angle in half, okay, if you go to that line and meet at one point going at a perpendicular to the line that you have here, this is going to cause these two to be congruent as well. Okay, and then let's go to our new vocab words. Circumcenter. Now, if you do perpendicular bisectors of a triangle, which means you go perpendicular and you cut the side in half and you go straight up. And then you do the same thing on this side and you do the same thing on this side. I didn't mark these, so let me mark them. Okay, so each side has been cut in half and a line has been made in it. They meet right here. This is the center of a circle that goes around this triangle, touching all of these sides perfectly. Meaning that from this dot to any of the corners is the radius of the circle that goes around the shape. Now, so circumcenter uses perpendicular bisectors, so it cuts the sides in half, okay, to find a circle that perfectly touches all of the angles. Which brings us to incenter. Incenter is where the angle bisectors meet. So the angle bisectors meet here. And this is the exact center of the circle that will perfectly touch all of the sides. Okay? Meaning that this dot is the center of the circle inside. So these lengths here, from here to here, from here to here, from here to here, are going to be the radius of the circle. So the angle bisectors make a point that is equidistant from all the sides, and the perpendicular bisector finds a point that is equidistant from all of the angles, which means circumcenter and incenter are the opposites of each other. Mind blown. End video.